Hey everybody, welcome back. Here we are with another lesson in AP Environmental Science curriculum. This one is Unit 3, Lesson number 2, K-selected and R-selected species. Now we talked about R-selected species very briefly when we discussed invasive species, but with this lesson we're going to go in depth talking about the differences between K-selected and R-selected species. Now, the one thing about this is that it is not that long of a lesson. I think the next couple are not that long. There is one larger lesson in Unit 3, but for the most part, they're a bunch of short lessons. So without further ado, let's figure out what the College Board wants us to know. Now, the College Board wants you to be able to identify differences between K-selected and R-selected species. Now, and it goes into all the essential knowledge associated with it. And I think we're going to do a pretty good job of summarizing that over the next couple minutes here as I go through it. So, what is K-selected and what is R-selected? Well, what they are is they are reproductive strategies. So, this is the way in which an organism reproduces, and it's really linked to population growth and population rebounding, and then that actually links into a lot of other ecological concepts. So, what the one thing that we have to remember is that humans will reproduce year round. Why are we able to reproduce year round? Because we've modified our environment to the point where we can now produce food year round. If you look, you go to the grocery store, you can find peppers and tomatoes year round because they're grown in greenhouses in different areas and flown in because we live in a globalized society. That food abundance allows us to be able to get nutritional values, which then we can continue to use and continue to grow our populations. We don't have a season where we struggle to survive. Everything actually is available to us at all times, and that allows us to do well and reproduce at any time. 90 other percent of the planet's animals and whatnot, and even plants, do not follow that protocol. They are reliant upon abundances of food, safety, different other factors that go into when they are able to reproduce and why they reproduce at those times. K-selected and R-selected, again, is a reproductive strategy. And what we're really looking at is how frequently do you have offspring and how much parental care do you put into raising those offspring. Humans, for example, when you reproduce as a human, most of the time it's one offspring, but yes, you can have two, three, or more. But for the most part, it's a single birth at a time. We then spend a lot of energy raising that baby or that infant to an adult size, and then we focus in on that, and we're not reproducing like 3-4 times a year. It doesn't work that way. There are other organisms which will produce thousands upon thousands of offspring at one time with no parental care. It's just kind of a good luck, and maybe I'll see you at adulthood situation. And those two different things really make up the basis of the R strategist versus K strategist. In this picture here, you can see like kind of the idea that this is not just one or the other. Okay, it is not like you are either R strategist or you are either K strategist. It is oftentimes a spectrum, and organisms fall somewhere into that spectrum depending on the amount of offspring. Now, what I will often say is, even looking at this picture, I'd probably draw the line of the rabbit and going to the left as the organisms that are R selected, or normally would be classified as R selected. Usually, if you're only producing 1 to 2 offspring a year, you're more off to the K selected side. Now, what is this really based on? And this is based on something called biotic potential. And what we're really looking at is how fast can a population grow. The biotic potential is the absolute fastest rate a population can grow if all limiting factors are available. You have enough food, you have enough water, you have all of those things. You live within that tolerance zone where you can focus in on reproduction because you know you are safe in all the other categories. That is how we can measure our true biotic potential. Biotic potential is often represented with an exponential growth curve, or what we would commonly refer to as a J curve. All right, and what happens is it means that as you're reproducing at a fixed rate, so this is actually a fixed rate. It's just like a percentage. You know, maybe it's 2, 3%, maybe it's 10%. Who knows what the rate is? All right, it will just continue to go up. Now, the thing is, we're going to eventually learn about the idea that an ecosystem has a limit to how fast a population can grow, and it's going to start to slow that down. So let's get started. First off, talking about K-selected species. The K in K-selected species is in reference to carrying capacity, which we're going to talk about in 3.4. Now, I know what many of you are saying. Carrying capacity doesn't start with a K. What I believe it to be derived from is a German word. Germans really did a lot of the initial research and have a lot of the initial ecological theories established. So a lot of zoology, a lot of ecology is based off of German science. When you learned about the cell theory, you learned about two very famous German scientists, Theodor Schwann and Matthias Schleiden, who identified that all plants and all animals are made of cells. So that's where the K in K-selected. So just try to remember K is carrying capacity because these organisms, their populations usually exist at the carrying capacity for the ecosystem. Therefore, they're not going to need to have massive population growth or rapid population growth because they're already at their max population for that ecosystem. What are some general characteristics? Again, these apply to that spectrum. If you hit most of these criteria, you're probably a K-selected species. Are you usually a larger organism? Okay, most of our small organisms reproduce very, very rapidly, but some of our small organisms do take some time. But for the most part, we're saying larger organism like, I don't know, bigger than rabbits, bigger than squirrels, but smaller than, there's also organisms smaller than humans that are K-selected species. Do you have few offspring per reproductive event? So meaning a small brood size or litter size. If you are only producing 1 to 2 offspring at a time versus thousands or even 10 to 15 with some animals. Different types of organisms produce different amounts of offspring at a single litter. Do you have a long gestational period? Elephants, their gestational period is about 18 months. Humans, we know, is about 9 months. It's how long are they in the womb. If you have a short gestational period, you're able to produce multiple broods per season. So some birds like robins and different other things that you'll see during the summer around here, they might have 2 to 3 sets of offspring a year, just because they're able to produce that first one early. Then they raise them. Hopefully they fledge the nest, and then they'll go and try to reproduce again if food is available, if all those limiting reactants are available. Now that's not the same as humans, which again you can't have 2 offspring in a calendar year. Yes, I know you can in theory, but for the most part we don't. High energy involvement or investment in raising the young, so they mature in a long period of time. Every year, I get questions always asked about, what is this? Oh, it's a small bird outside flying around, so it has to be a baby. Birds, in order for them to leave the nest, are fully grown. So when birds leave the nest, they are fully grown. So it's not like you see a bird in flight or a hawk in flight and say, oh, that's a baby one of these. No, that never happens. It might be a young or an immature because it hasn't developed its full adult plumage or feathers yet. But the idea of it being a baby is not the case. So it's not like you see a baby eagle in flight. Now, when eagles take flight, they're fully grown. Now, humans, for example, we have to raise our young. We have to raise our young. It's not like anyone's just, 4 months of being raised and then all of a sudden you're on your own. No, it doesn't work that way. And there's a lot of other organisms which spend an immense amount of energy raising their young, protecting them, making sure they reach their own adulthood or maturity levels. What's the life expectancy of the organism? If the life expectancy is quite long, it's probably a K-selected species. It's pretty sure it's probably going to be an R-selected species. And then K-selected species are often predator species, but there are a lot of exceptions to this. Things like elephants are not predators. You're not going to see an elephant hunting down different animals. But the idea that a lot of our predators can fall into the K-selected species more than the R-selected species category. It's just more of an observational stat. I don't really know the true data on that one. So let's compare some of our examples here. Obviously, things like the gorilla, the silverback, or mountain gorillas, they take a very long time to have offspring. They make sure the conditions are proper. Kangaroos, elephants, hippos, but that's also why their populations don't rebound very, very rapidly. And over here on the right-hand side, you can see a list of different organisms and their gestational period. So how long are they actually in the womb or in utero? And you can see different things from elephant at 645 days to things like seals at 330 days, so almost a year for seals to have an offspring. Various organisms have different gestational periods. Now let's go to the converse. Let's go talk about some of our R-selected species. I'm going to go through this a little bit more faster because we just kind of talked about the K. The R is pretty much the opposite. R, think of rapid because they can go through rapid population growth. The other way to remember is rabbit. Rabbits are an example of R-selected species. So if you kind of put letters to different ways of remembering things, this is a perfect way for you to address that. Let's go through some generalities. Again, they're generalities. They're not always the case, but just be aware. They're usually smaller organisms. They oftentimes have many offspring per brood. They're going to have little to no energy investment in their offspring. Think of like a sea turtle, for example. A sea turtle will go up, it'll lay its eggs, and then it will never ever see those offspring. They lay those eggs and then they're gone. They bury the nest and they hope that everything survives. They oftentimes, the individuals will mature quite rapidly. All right, now it's not always the case. Again, sea turtles take a while to reach full adulthood. But for most organisms that are R-selected, they are going to mature quite rapidly, much more rapidly than like a 15 years for a human. They oftentimes have shorter lifespans. Again, not always the case, but they usually do. They're often prey species. Again, not always the case. Populations fluctuate rapidly. That usually happens. They're going to see populations go up and down, mainly because they're prey. Remember, we talked about that predator-prey cycling in the very first lesson. The idea that you have to have predators, or you have to have prey before you have predators, and their populations go up and down and up and down. That fluctuation is an example of R-selected species, usually the prey species, which populations are much larger because, again, we factor in trophic levels and the idea that certain organisms, in order for us to have high-level predators, we have to have a heavy base of prey species. And finally, they can become invasive species if they're introduced to a new environment, which we already talked about. So here's some examples. Again, sea turtles, praying mantis. Here you have fish, and this is salmon, just showing how many eggs are inside here, tadpoles, and different other types of amphibians, which will lay many, many eggs at a time, hoping that they reach full adulthood. Again, here's a little comparison between the two. And again, you're looking at how the K-selected compares to the R-selected species. We're looking at the way in which different organisms react to this and how their populations fluctuate. Now, to recapping this thing, we have K-selected species, we have R-selected species. K-selected species, they are going to be generally larger, take a long time to mature. Their populations usually exist up at the carrying capacity. Compare that to R-selected species, usually smaller, but they reproduce far more rapidly. Because what happens is the population goes through boom and bust. So it goes up and down, up and down, up and down as you go through their life history. So make sure you can be able to tell the difference. Make sure you understand why they're different. Again, these are just reproductive strategies. These are different ways organisms have evolved to be on the planet. Make sure that you understand general characteristics as far as size, reproductive rates, parental care, all of those major factors associated with it. If you feel comfortable, you know what you're doing, fantastic. If you don't, get in contact with me. If you enjoyed this little lesson, hopefully you're willing to stay a little longer for the next lesson, and I'm looking forward to seeing you. So thanks for tuning in, and have a good one.
You like that lesson? I know you did. So why don't you go ahead and smash that like button right now. Go ahead and comment. Tell all your friends about how great that lesson was. And make sure you subscribe, because I'm going to keep bringing you AP environmental content that you're going to want to watch. Or do whatever else those other YouTube channels tell you to do. And with that, Maloney, out.